Welcome to Global Future School. Students, this is your first year chemistry class. I am Dr. Jalpanu. The topic for today's discussion is Valence bond theory from chapter 3. Students, Valence bond theory, actually this is the theory of covalent bonding. And after completing this Valence bond theory is very simple. That tells you about the features of sigma and pi bond, and this will also help you to understand the formation of single, double and triple bonds, and how the sigma bond is related to single bond and pi bonds are related to the multiple bonds. Multiple bond means double or triple bonds. Students, in 1927, first of all, Hitler and London proposed this theory, and later on it was developed by Pauling. And according to them, the concept of Valence bond theory is based on wave mechanical treatment of the molecules, and this helps to successfully in explaining the bond energy, that is very important, bond length and shape of molecules. So the important features of molecules that are bond energy, bond length and shapes of molecules. This theory helps to understand on the basis of wave mechanical treatment of the molecules. And secondly, they tell that a covalent bond between two atoms is formed when atoms come close to each other. So before bond formation, there is a must conditions that atoms should come close to each other. And also the overlapping of atomic orbitals, they retain their identity. So the orbitals that are forming the bond, that are participating in overlapping, they retain their identity. They do not lose their identity. Their basic shapes they do not lose, according to scientists in Valence bond theory. And the postulates of Valence bond theory, they are very simple and easy to understand. First of all, a bond between two atoms is formed by the overlapping of half-filled atomic orbitals of two atoms. So just understand, a bond is formed between two atoms. So these two atoms, they must have a partially filled atomic orbitals, and when partially filled atomic orbitals means they have one electron in orbital. You know, an orbital maximum contains two electrons. So half filled or partially filled means they must have one electron in their valence in the orbitals, and then they overlap to form a bond. Second, the two overlapping orbitals must have electrons of opposite spin. In their singles, in their orbitals, in their relevant orbitals, they may be a sigma, maybe a clockwise or anti-clockwise spin, but when they paired, then they have a opposite spin, a paired spin, like one electron will have an anti-clockwise and other will have clockwise spin. And the number of bonds formed between them is equal to the number of unpaired electrons present in valence shell of the atom. So who will decide how many bonds will be formed? Bonds depends upon the number of partially filled atomic orbitals. So if atom has contained one partial filled atomic orbital, it will form a one bond. If it has more than one, or two, three, so the bond will be formed according to the number of partially filled atomic orbitals. If only two orbitals overlap, of course they will form a single bond. If two orbitals will overlap, they will form two bonds. If there are three orbitals overlap, they will form triple bond. So bonds depends upon the number of partially filled atomic orbitals. In order to form a bond, how to form the bond? The overlapping orbitals must have the same symmetry. So this is the condition, they must have the same symmetry. Like if they are px, so 2px, so they will be on the same axis, they will overlap. If they are on the y-axis, so they will overlap. It is not px and py will overlap, because they have a different symmetry. So they have the same symmetry with respect to bond axis. Bond axis basically is the line joining the nuclei of two atoms is called the bond axis. nuclei of two atoms that join to each other, that line is called the bond axis. I will explain you in the later slides. In overlapping of orbitals, energy is released. Whenever a bond is formed, overlapping means a bond formation. Whenever a bond is formed, energy is released because bond is stable form. So in going to stability, energy is released. The greater the overlapping between the orbitals, greater is the energy released, and the stronger will be the bond formation. So you can say like a single bond is formed, then energy will be released. If a double bond means more bonds are formed, more overlapping, so more energy will be released. And triple bond, there will be even more energy released. In sigma bond is stronger than pi bond because in sigma their overlapping is greater as compared to pi bond. That will explain in the upcoming slides. So how many types of overlapping and what are their nature? So basic types of overlapping are two, that is sigma and the pi bond. Sigma bond is like head-on approach and pi is like a parallel. Sigma bond, this is represented by a sigma single, sigma sign. Sigma bond is the any first bond that is formed between two partially filled atomic orbitals by head-on, head-to-head, or end-to-end, a linear overlapping, or is called sigma bond. And sigma bonds can be between S and S, it can be between S and P, it can be between P and P. I will explain you with the help of examples as well. First of all, first type is like S and S. How it is between S? Like if you have a S orbital, it has like one electron, and this is the center electron I am drawing here, and this is the nucleus. Other 6s also has like one electron. Now when they will overlap, they overlap this region, this one. So now their spin is both electrons, this is like in a paired spin. So this is the line joining the two nuclei of the two atoms. This is called the bond axis, and this bond is like S and S, sigma bond. So in this case, the electron density lies around the bond axis. Electron density lies around the symmetrically distributed around the bond axis, and this is the S and S sigma bond. So in case there is S and P, like you have one S and one of the P atomic orbitals, so it has one electron center, so these will join and they will like this. So this is bond like S and P sigma bond, and this is the line joining the two nuclei, and their behavior will be like this. So this will be the bond axis. So their bond electron density lies around the nuclear line joining the two nuclei. There is other possibility between P and P. So first they can be 2px, they can be 2py, and they can be 2pz. So like you have like this one px orbital, so it has one electron in it, it has one. So this at this spot they will join like this one, and now they have the pairs. Or you can say this is like this region, this is the line joining the two nuclei, and in this way this is like electron densities around the line joining the two nuclei. So this is P and P sigma bond. So sigma bonds are S and S, SP and P can be. And what are the features or particulars of the sigma bond? First, sigma bond is formed by head-on overlap, or you can say head-on head, end-to-end. The linear overlapping is called the sigma bond. Electron density is symmetrically distributed around the bond axis. I already explained you that electron density is symmetrically distributed around the line joining the two nuclei of the atoms. Probability of finding the electron is maximum in the region between two electrons. So two nuclei, here will be the probability of the electron. First bond formed between any two atoms is always sigma bond, of course. First bond, either it will be between S and S, it will be S and P or P and P. The first one will be always a sigma bond, and that will be a first bond is sigma bond. All sigma bonds are all single covalent bonds are sigma bond. Of course, the first bond, that is sigma bond that is called a single covalent bond, like H2, H and H, it has a one bond, HF, F2. So these are the single covalent bonds, they are sigma bond. So bonded electrons are called sigma electrons. The electrons which are shared between two atoms and they form sigma bond, so those electrons will called sigma electrons. Other type we have the pi bond. Pi bond is always formed by parallel overlapping or sidewise overlapping of the two partially filled atomic orbitals. A bond formed between two already bonded atoms, and the condition is first bond. I already told you the first ever bond will always sigma bond. So if that is already bonded and has the sigma bond, then by the second other partially filled orbitals, and they will overlap sidewise or parallel of their two half filled p atomic orbitals whose axes are parallel is called a pi bond. Like P and P, I take the example like this one. I'm naming it PY, and this one is other PY. So this is the lines, and now they are joining. Both have one electron, so they will overlap from this region like this. So this area is shared, and now they have the pair spin, and there the line joining the two nuclei. In this case, electron density lies above and below the line joining the two axes. So these are less efficient. They because the electron density is distributed above and below with the line joining the two nuclei. So they are weaker as compared to sigma bond. And pi bond is formed where there is always first a sigma bond, then a pi bond is formed, and in this case they have the symmetrical because they are on the py and p. But in case if you have like px, but px and py, they will not form the pi bond. So this is the condition that they have the same symmetry, they should be on the same axis. The particular like pi bond is formed by sidewise, or you can say side to side, or you can say parallel overlapping between two p orbitals. Probability of finding the electron is maximum in the region above and below the line joining the two nuclei. Hopefully it is clear. The sidewise overlapping is not too efficient because electron density is not distributed above and below, so this is a weaker bond, less efficient. So result is a weak bond. That's why sigma bond is always stronger than a pi bond. One or two pi bonds can form between any two atoms they are already covalently bonded. I already told you if they are already covalently bonded, they have already a sigma bond, then one or two pi bonds are formed, and those pi bonds electron will be called pi electron. The question is why sigma bond is always stronger than pi bond. I have already explained you. So describe this, why sigma bond is stronger than pi bond. Question can be asked why pi bond is weaker than sigma bond. Now I will apply the these features of sigma and pi bond, and we will look how the sigma bond is formed. First example is like H2. Hydrogen, its electronic configuration is 1s1, so it has a spherical shape. Nuclei, it has one electron. Other hydrogen also have 1s, so because these are two, one hydrogen and this is the second hydrogen. This is first, so this will also have like this. Now they will linearly overlap, a head-on approach. 1s and 1s both have one electron. Now this is like paired spin, so they occupy this region, and this is S and S sigma bond. Now I will take the example of chlorine. consider Cl2. One chlorine, its atomic number is 17. Other chlorine also have. So first draw its electronic configuration: 1s2, 2s2, 2p6, and 3s2, 3px, 3py, 3pz. 2 to 4, 6, 10, 11, 12, 13, 14, 15, 16, 17. So it has one partially filled atomic orbital. It means it will form a single bond. Other chlorine will also have like this. I am just writing the valence electron, 3py and 3pz. This single can be in py. In case py it has single, then the pz had a pair. So only one is like this. So they will be formed only single electron. So now draw the p orbitals on chlorine. Like I name this one. So this is like just according to your easiness. This is like px, and this is like pz, and this is like py. Okay, it has one electron. So second chlorine, it will also have like this pz, one electron. They have px, both electron, and in py also 2 electrons. So they will not participate in the bond formation. Only these two, pz of one chlorine and pz of other chlorine, that has one electron. So now their spin is paired. So this region will be occupied. So pz pi bond will be formed. So now what about the HF? And you know fluorine has atomic number 9. 1s2, 2s2, 2px, 2py, and 2pz. 4, 5, 6, 7, 8, 9. So it has also one. So it will form a single bond. And hydrogen, you know, it's 1s1. So this is of hydrogen and pz of fluorine. So it will form, this is s and pz. S and 2pz sigma bond in HF. So now it will be clear in the upcoming animations, and this will be more clear. I have already told you along with the electronic configuration, if there is one partially filled, it will form a single bond. So these are the examples of molecules that have the single bonds.
The simplest molecule we can discuss in terms of valence bond theory is the hydrogen molecule, H2. This molecule is formed by two hydrogen atoms sharing their 1s1 electron. When the atoms approach each other, their 1s atomic orbitals overlap. We can envisage some merging of the orbitals to form a common electron cloud containing two electrons of paired spins. Electron density in this cloud should be concentrated somewhere between the hydrogen atoms. The covalent bond formed by overlapping the two s orbitals is termed a sigma bond. Hydrogen atoms are linked by a sigma bond in the hydrogen molecule. Fluorine atoms have 7 electrons in the valence shell, 2 in the 2s and 5 in the 2p orbitals. The 5 2p electrons are distributed among the 3p orbitals in such a way that 2 of the orbitals are filled with paired electrons, while the third one has a single electron. Only the last mentioned is available for forming the covalent bond by sharing its electron with another atom. Consequently, a covalent bond can be formed by the overlapping of singly occupied p orbitals. A bond produced by such head-to-head overlapping of p orbitals is a sigma bond. Both hydrogen and fluorine possess a single electron which can be shared with the other atom. They are in different orbitals, 1s in hydrogen and 2p in fluorine. but they can still overlap to form a covalent bond. The bond formed by the overlapping of s and p orbitals is a sigma bond too.
So now we will look how a double bond is formed. If an atom will contain two partially filled atomic orbitals, then a double bond will be formed. Look at the example O2. Oxygen, you know atomic number of oxygen is 8 and its electronic configuration is 1s2, 2s2, 2px, 2py and 2pz. 2, 4, 5, 6, 7 and 8. So it has two partially filled atomic orbitals. So oxygen will form two bonds. Other oxygen, this also have the same electronic configuration. 2px, 2py and 2pz, this one. So because they contains two partially filled atomic orbitals, so they have a double bond. How it is formed? Like write the oxygen and draw all the px, py and pz atomic orbitals on it. Consider this is py and this is pz, and I am representing pz with these dots. This contains one electron, py also one electron, and p x, like this one is px, it has two electrons in it, like this one, this is two electrons. So other p on oxygen electronic configuration is same for the second oxygen. This is like pz with these dots and a single electron. This is like py and it has one electron also, and pz, this is like it has two electrons in it. So this is completely filled while those other are partially filled. First bond will be formed by linear overlap. So py and py, 2py and 2py, they will form a sigma bond. Now this is fixed sigma bond, a single bond is formed. After that I will look which one have the parallel spin, like pz and pz, they are parallel to each other, both are on z axis. pz cannot form bond with px because they have different symmetry, and also px has the paired electrons. So they parallelly will overlap and will form a pi bond. So pz and pz, they will form pi bond. So two bonds are basically formed between oxygen. First one sigma bond and second one pi bond. So oxygen has a double bond, sigma and pi bond, and double bond is more stronger than single bond because single bond energy released during single bond formation, and in double there will be more energy released and more stable bond will be formed. So sigma double bonds are stronger than single bond. S2 is just like that of oxygen. Its valence electronic configuration is just same, like 3px2, 3py1 and 3pz. It will contains two partially filled, so S and S, they contains double bonds. Now look for the how a triple bond is formed. Of course, if the atom will have three partially filled atomic orbitals, you know atomic number of nitrogen is 14. Its electronic configuration is 1s2. Sorry, atomic number is 7 and atomic mass is 14. So 7, 1s2, 2s2, 2px, 2py and 2pz. 2 to 4, 5, 6, 7. So here it is clear that it has three partially filled. It means nitrogen can form three bonds, a triple bond. Other nitrogen also will have the same electronic configuration, 2s2, 2px, 2py and 2pz. All contains one electron, are partially filled. So three bonds, how these are formed? So draw all the X, P, Y, P, Z. So consider this is Px, this is Py and Pz. So I am filling Px with dots, it has 1 electron. So I am filling this Py with dash lines, it has 1 electron. And Pz is empty, it has also 1 electron. Other nitrogen, this is the first nitrogen and the second nitrogen will also have the same configuration. Like this is Py filled with lines. This is like Px filled with dots, 1 electron, and Pz, this also contains 1 electron and that is empty. So how first bond will be formed? Either this formed between Px or is formed between Py or Pz. First bond will be sigma. This is Px, this is Py, and this one is Pz. So first bond, this will be a sigma bond, that is between Px and Px sigma bond. Second will be who have the symmetrical on the axis, like Pz and Pz. They are parallel to each other. Pz is not parallel to Py, but Py and Py are parallel. So this is a bond between Py and Pv. And now Pz and Pz are parallel, so they have pi bond. Second pi bond is between Pz and Pz. So total are 3 bonds between nitrogen. First one is sigma and these two are pi bonds. And this bond is even more stronger and stable as compared to double and single bond. And it is because 3 bonds are formed, so more of the energy will be released and a stable bond will be formed. P2 also have the same, just like nitrogen. Its valence orbitals have 3 partially filled valence orbitals, so it will form a triple bond. So this was all about the single, double and triple bond. Now question is, differentiate between sigma bond and pi bond. So you have a greater knowledge and clear concept about the sigma and pi bond. And why sigma bond is stronger than pi bond, I repeatedly told you about their strength. Now draw the shape of HCl just like HF. F2 is just like Cl2, S2 just like oxygen, and it's just like N2 on the base of Valence bond theory. So go and practice to draw the shapes of some of the other molecules also. So this was all about the Valence bond theory, their postulates, and how sigma and pi bond, what are their features, particulars, and how sigma, single, double and triple bonds are formed. Our next topic will be the atomic orbital hybridization, and the hybridizations are of 3 types: sp3, sp2 and sp.